In this lesson, we will discuss graphs of motion. So we often use graphs to show how something is moving. One of the most important graphs that we use is called a position time graph, or sometimes a PT graph. In this case, time is our independent variable and goes on the x-axis, and position is our dependent variable and goes on the y-axis. So if you have a straight line on a position time graph, that is going to mean that you are traveling at a constant velocity. So here we have a few examples, and I have a bicycle. So the bike, if it is moving to the right, we're going to say that that is going to be a positive direction. And if it's moving to the left, that's a negative direction. So you'll notice my first graph, I have a straight line with a positive slope. That means I start off and I go at a constant velocity. We know it's a constant velocity because the line is straight, and that I am moving straight forward. I know that I'm moving forward or to the right in this case because my line is going up. And we know that if a line is going up like this, it has a positive slope. So if my graph has a positive slope, that means that I am moving in a positive direction. And actually, similar thing, if you have a negative slope on your graph, that means you're moving in a negative direction. In this case, it doesn't mean that the bike is going backwards, although it certainly could. It just means that the bike is going in the leftward direction. And if you look at this last example, you'll notice that the position is unchanged. This means that the bike is not moving because the position is the same at every interval. So for this next problem, they tell us a bus drives 40 kilometers per hour to the east for 30 minutes, then stops for 5 minutes, then drives 60 kilometers to the west for 10 minutes. So they ask us to do two things. They first ask us to draw the motion graph, and then they ask us to calculate the displacement of the bus. So we have two options in this graph when we're writing out the time. We can either do the time in hours or we can do the time in minutes. You'll notice that our speed, our velocity, this is they do give us a direction, so it's a velocity. Our velocity is in kilometers per hour, but they actually give us minutes. So we have conflicting units. At some point, we are going to need to convert units. So you can either do this in hours or in minutes. Now, it's a lot easier to draw the graph in minutes in this case. Like, for example, if you notice the middle part, they say it stops for 5 minutes. If I had like 1 hour here, 5 minutes on the graph is pretty hard to figure out where it is. It's going to be 1/12 of this. It's probably going to be somewhere like that, but we're not actually going to do that. That makes the problem a lot more complicated. So instead of doing that, we are going to do our time in minutes instead of hours. So if I add up all the minutes that I have 30, then 5, then 10. That's a total of 45. So that'll kind of tell me how many tick marks I need to make on my graph. So I think since I have about 45, I think it's a good idea to go by fives. So I'll start and I'll start with 5. Make sure that your spaces are even. I'll go ahead and draw the rest of them out for you. So here is my x-axis where I have the time. Since they don't tell us anything about a starting position, we're going to assume that the starting place is just going to be right at 0, 0. So I'm going to put my point there. Here comes the next challenge in this problem. We need to figure out our positions after a certain amount of time. So the first thing they give us is 40 kilometers per hour. They don't actually give me a position there. They just tell me how quickly I traveled. However, I know that if I have an average speed and a time, I could multiply those together to get the distance that I'm traveling. So we're going to be using the formula D equals V bar, which means average speed, times T. By the way, if you can hear my son in the background, I'm sorry about that. It's almost his nap time. So I'm going to be finding my D. Here's the issue I have. I have that my velocity here is 40 kilometers per hour. The other thing I know is that my time is 30 minutes. These are not the same units, so you have a few options. You can either change from kilometers per hour to kilometers per minute, or you can change 30 minutes to hours. 30 minutes we know is a half an hour, so that one's actually really easy to deal with. You're just going to do 0.5 hours. Now that I have the same units, I can multiply these together. So I end up getting 40 kilometers per hour times 0.5 or 1/2 hours. Hours and hours cancel out, which is good because then I'm just left with kilometers. 40 times 0.5 is just going to be 20 kilometers. So now what I can do is I know that after 30 minutes, I have traveled 20 kilometers. So I can actually put that onto my graph. And actually that is the furthest I'm gonna go because after I continue driving, after the bus continues driving, it's gonna go in the opposite direction. So I'm just gonna go ahead and go by 5s again, all the way up to 20. And so then we decided that 30 minutes is going to correspond with 20 kilometers. So that's going to be a point right here. I don't actually know if the bus driver is speeding up or slowing down or making stops every so often. We're just going to assume that the driver is going at a constant velocity, which we can see drawn on the graph with a straight line. If the driver wasn't going at a constant velocity, it wouldn't be straight, but since we're going to make that assumption, then we can do that. So that's the first part of it. The next thing we know is that the bus stops for 5 minutes. So that means that 5 minutes after the first 30 minutes, I'm going to be at the same position, which is 20. So I can actually draw another dot at 35:20. And on my position graph, because the bus is not moving, that's going to just be a straight line. The next thing that's going to happen is the bus is going to turn around. They tell us in the next part that the bus is going west. Bus is actually going 60 kilometers per hour to the west for 10 minutes. So in this part, I want you to think about, you can pause the video if you want, try to figure out what is that distance actually going to be. So I'm going to use my same formula. I know that my distance is 60 kilometers per hour. I don't actually have the time in hours. However, since I know that there are 60 minutes in an hour, I know that means that 10 divided by 60 is the number of hours, or we can say it's just 1/6 of an hour. This one's actually really nice because you'll get a good, nice numbered answer in the end. When you multiply this out, your hours and hours are going to cancel out. You just end up getting that the distance traveled in the next 10 minutes is 10 kilometers. So what I'm going to do now is 10 minutes after the bus had finished stopping is going to be at 45. And then I'm going to draw a point at 45. And because I was at 20 kilometers away from where I started, but I turned around and came back in the direction that I started from, I'm actually going to be 10 kilometers away from where I started. I just want you to note that the 10 does not come from the distance that the 10 doesn't come from this. The 10 is going to be this distance right here. So I started 20 kilometers away, then I went another 10, so I would do 20 minus 10. I'm now 10 kilometers from where I started. So this is actually going to be my graph right here. Everything except the green is the perfect right answer. The last thing they ask you to do is calculate the displacement of the bus. And I actually just did that, believe it or not. So the displacement is going to be how far away you are from where you started. So how far away the bus is from where it began. And we actually already figured that out. It is going to be 10 kilometers from where it started. And that is my displacement answer.